Hi everybody. In this lecture, I'm going to talk about how to set up a bidirectional replication in Oracle Golden Gate, Part 1. By the end of this lecture, you should be able to understand how the bidirectional replication works in Oracle Golden Gate, understand the challenges in implementing a bidirectional configuration, and finally understand the data looping issue and how to prevent it. This is the typical structure of a Golden Gate architecture. As usual, you would have the primary extract process, trail files, and the data pump process in the source side. And you would have the trail files and the replicate process in the target system. All what you have to do when you configure the bidirectional configuration is to mirror this architecture in the other direction. You configure a primary extract, trail files, and a data pump process at the target system. And you configure remote trail files and replicate process in the source system. With this configuration, any changes made to the data in the source database will be sent to the target database, and any change made to the target database will be sent to the source database. So this architecture allows the two databases to be in sync, and in the same time, the application can connect to any database. The bidirectional configuration can be extended to allow more than two databases to participate in the configuration. This is called multi-master topology. As is the case with the bidirectional configuration between two databases, the applications can connect to any database in the configuration, and Golden Gate tries synchronizing the data among the databases. One of the databases should be considered as the trusted source. This is the database from which the other databases is derived in the initial synchronization phase and in any subsequent resynchronizations. The bidirectional configuration in Oracle Golden Gate is supported in heterogeneous configurations. It represents an active-active replication among the databases. It is supported in the databases Oracle, SQL Server, MySQL, SQL-MX, Sybase, Teradata, and DB2. This configuration increases the availability and the performance of your system. One of the scenarios where this configuration could be highly advantageous is when you have the databases located in far distance between them. The application will connect to the local database, and Golden Gate will take care of the synchronization between the databases. This solution highly enhances the performance of applications in all the locations. You may have noticed from the bidirectional architecture diagram that it's very similar to the unidirectional configuration. You just have to mirror the processes in the databases. However, building up a successful bidirectional configuration is not as easy as it might look like. There are a lot of challenges that you have to plan to resolve them. Actually, in some cases, the bidirectional configuration cannot be used. First, you have to study the application. Many out-of-the-box applications do not support Golden Gate bidirectional configuration. You have to consult the vendor to make sure whether Oracle Golden Gate bidirectional is supported or not. You also may need to change the way your application is generating the primary key values. You need to maintain the uniqueness among the primary key values in all the databases. You need to make a little configuration setting to handle truncating table commands. This is because the bidirectional configuration doesn't automatically replicate the truncate table statements. Triggers may generate DML operations. Those operations will be replicated by Oracle Golden Gate, causing a conflict when they are applied in the target database. To prevent the local DML from conflicting with the replicated DML from these operations, you need to modify the triggers so that they don't perform DML operations as a result of executing replicate DML operation. Luckily, this is not needed if you configure the integrated replicate. Integrated replicate handles triggers without any additional configuration. You must also do some configuration to prevent the DML operations to get into an endless loop in the databases. There are many options in Golden Gate to address this issue, and we are going to study them in details in this lecture. Practically speaking, in a bidirectional configuration, data conflicts cannot be avoided. You need to put on a plan to manage them, and Golden Gate provides a lot of options to implement your plan. This challenge usually takes most of your time when you plan for building a bidirectional configuration. I will cover it in the next lecture. As is the case with the unidirectional configuration, it is highly recommended to have primary key constraints or unique constraints on all the data tables in the databases. If you don't do that, Golden Gate will use the data in all the columns to distinguish the records. Of course, this will degrade the performance. The mechanism to generate the primary key values in the databases must be reviewed before you go ahead with implementing the bidirectional configuration. You need to make sure that the uniqueness is maintained in all the databases across the configuration. For example, if you are using sequences to generate primary key values, you can prefix the generated values with a number that specifies the database. Truncate table statement is not supported in bidirectional replication, but it is supported in unidirectional replication. For this reason, you need to configure the truncate parameter in one database. You always truncate the tables from that database. On the trusted database, configure the extract and the replicate processes to have the getTruncates parameter configured in their parameter files. This allows truncate table operations from the other databases. On those other databases, configure the extract and the replicate parameter files to contain ignore truncates parameter. So you end up with a configuration where you truncate the table in one database, and that truncate operation will distribute to all other databases. If the cascaded deletes constraints are configured in your database, you actually need to disable them and replace them with the triggers. Depending on the database platform, you may need to add some code to the triggers as well. Fortunately, the integrated replicate handles the cascaded delete constraints automatically. You don't need to make any modifications to handle them. The example in the slide is showing a code sample of a trigger in an Oracle database. It checks out the owner of the DML operation that fired the trigger. If the trigger was fired by a DML executed by the replicate process, the trigger is not going to execute its code. If your replicate is not operating in the integrated mode, you should do the same in all the triggers in your database that are associated to the replicated tables. If your replicate is not operating in the integrated mode, You should do the same in all the triggers in your database that are associated to the replicated tables. If you have onDelete cascade constraints created in the database, you need to disable them and convert them into triggers that will perform the cascade delete operations for you. This is important because the onDelete cascade constraints generate DML operations to achieve their task. Fortunately, Integrated Replicate handles those constraints automatically. If you have Oracle 12c as your target database, configure your replicate to operate in the integrated mode.